There is another way of classifying chemical reactions. So the previous section we talked about composition, decomposition, single replacement, double replacement, combustion reactions. There's a different way. It overlaps a lot with the types of reactions that I showed you previously. But basically, another way of classifying chemical reactions is based on whether they absorb heat or energy or whether they release heat or energy. And I'll show you a couple of examples of that here. So don't get too worried about this graph over here. Don't get too hung up on it. The idea behind this graph is that they are basically showing you, think of it as the x-axis as being the left side of the reaction and the right side of the reaction. So over here, you're talking about the materials that you started with, which are called the reactants, if you remember. And over here on the right side, you're talking about the materials of the materials that you ended up with, which are known as the products. So that's sort of the x-axis explained. And don't worry about this hump here. It's not important for our discussion. The y-axis is the amount of energy that each of the molecules has in your chemical equation. So if you're high up on the y-axis, it means your molecules have a lot of energy. If you're down low, it means they have less energy. So the first type of reaction that's shown by this fancy curve here is basically where the materials that you start with, your reactants, have more energy than the materials that you end up with, more energy than the products. And hopefully you can see that. The energy of the reactants is up high, the energy of the products is down low. Because of that, if your reactants have more energy than your products, the energy has to go somewhere. It has to be released. These had a lot, these have little, so where did the energy go? The energy is basically released from the reactants, and it's just, think of it as being emitted somewhere. If you have a chemical equation or a chemical reaction that releases energy because the reactants had a lot and the products had little energy, so there must have been some energy released, that type of reaction is called an exothermic reaction. And so here are some features of exothermic reactions. Energy or heat is produced. What that means is you can think of energy or heat as being a product in the chemical equation. Another way of thinking about it is that heat is released. When you do an exothermic reaction in the lab, and you do an exothermic reaction in a test tube, what ends up happening is because heat or energy is released, the test tube that you're doing the reaction in gets hotter because energy is released to the outside world. The other way of thinking about it is shown here, that the products that you end up with have less energy than the reactants. An example of an exothermic reaction is one of the ones that we talked about in the previous section. This is sugar. You can think of it as glucose plus oxygen can make carbon dioxide and water. And it will also make some energy. Because energy is on the right side of the arrow, energy is a product. And you can see over here, energy or heat is a product when you have an exothermic reaction. Exo basically means outside and thermic means heat. So heat is released to the outside world. Heat or energy is produced. What this also means is that the energy of these molecules over here on the left is higher, it's up here, compared to the energy of these molecules on the right over here. They have less energy. And the difference in the amount of energy between the reactants and the product is how much energy or heat was released to the outside world. So that's an example of an exothermic reaction. It's also a combustion reaction, as we mentioned on the previous section. But in this case, we're focusing on the fact that energy or heat is produced. It's on the right side of the arrow in this equation. The other type of chemical reaction is basically the opposite of an exothermic reaction. It's called an endothermic reaction. Again, thermic means heat, endo means inside. So an endothermic reaction is heat or energy going sort of to the inside of the molecules, if you want to think about it that way. In an endothermic reaction, the materials that you start with don't have as much energy as the materials that you end up with. And because of that, the only way to end up with materials that have more energy is you actually have to add heat or add energy to these low energy molecules in order to turn them into higher energy products. And that when you do that, that's called an endothermic reaction. Some of the characteristics of an endothermic reaction are shown here. Heat or energy is a reactant. What that means is heat or energy will show up on the left side of the equation, on the left side of the arrow. Another way of thinking about it is heat is absorbed from the outside world and it goes into the molecules. So if you perform an endothermic reaction in a test tube, because heat is going into the molecules, it disappears from the outside world and your test tube ends up becoming colder. And again, I said this a few moments ago, but another way of thinking about it is the products in your chemical equation have more energy than the reactants in your chemical equation. And the only way to have that take place is if you add energy to your beginning molecules. You basically add heat or energy to turn them into higher energy materials. An example of that type of an endothermic reaction is shown here. Hopefully you see the energy or heat is shown on the left side of the arrow now. If you take 6 moles of carbon dioxide, 6 moles of water, and a certain amount of energy, you can actually make sugar and you can produce oxygen. Some of you may recognize this chemical reaction. It's basically the general chemical reaction for photosynthesis, which is how plants take carbon dioxide from the atmosphere. They use energy from the sun, and they use that, as well as some water, to make sugar that you and I can end up eating, that they can eat as well, and they also produce oxygen. So that photosynthesis is an endothermic reaction because it uses energy or heat from the sun to make higher energy molecules. That's it for endothermic and exothermic reactions. The other last little bit of information is a slightly different concept. Again, don't worry about this graph over here. It's important if you take more advanced chemistry, but it's not that important in this case. I just want to introduce the term catalyst for you. Basically, we have talked about chemical reactions throughout this section. So here's a chemical reaction on the previous slide, and the idea is that you can mix carbon dioxide, water, energy, and you'll make sugar and oxygen gas over here on the right. It turns out that many chemical reactions, even though in theory they can take place, sometimes they take place very slowly. An example of this might be this equation right here. You might mix 6 moles of carbon dioxide and 6 moles of water and add some energy, but it might actually take a very long time to make your sugar molecules and to produce your oxygen. This arrow here does not guarantee that this reaction will take place very quickly. There are, however, molecules that can be used to speed up chemical reactions. Any molecule that speeds up a chemical reaction is basically called a catalyst. So catalyst is just a chemistry term for some material that makes a chemical reaction go faster than it normally would all by itself. And there are many different types of catalysts. Catalysts are usually specific for certain chemical reactions. In other words, there might be a catalyst that speeds up this chemical reaction, but that catalyst might not speed up other chemical reactions. In fact, it probably doesn't speed up other chemical reactions. It usually only works for one specific type of chemical reaction. So, but in general, a catalyst is anything that makes a chemical reaction go faster than it normally would. So, as far as this section is concerned, what I'd like you to know is you should know the difference between an exothermic reaction and an endothermic reaction. And you should be able to answer the types of questions like this: which one releases heat, the exothermic reaction does, which one absorbs heat, which one has higher energy products, which one has higher energy reactants. You should also know what a catalyst does. Finally, I realize that this is probably one of the more difficult units for this course. If it's difficult, you should try to re-listen to the videos again If you're still having difficulty, you can go to a website called Khan Academy. Some of you who may have heard of it before, but Khan Academy sometimes gives very nice explanations of difficult concepts, in particular for chemistry. So there's a video on molecular formulas, there's a video on Avogadro's number, there's a video on these types of problems, limiting reagents and conversions with respect to moles and grams, balancing equations. There are videos for each of these things in Khan Academy, so you can poke around there if you're having difficulty as well. You should also try the suggested problems that are listed in this unit on Blackboard. So that's it for Unit 6. I will see you at the beginning of Unit 7.